This training is going to show OpenGate and OpenGate Query Analyzer. OpenGate Query Analyzer makes use of OpenGate. OpenGate itself is an ADO.NET based driver. Our in-house demo system here is client-server, so that's what I'll be using. So I choose the universe I want to connect in on. The user and password already defaults in because I've saved the connection already. I'm using headless node, meaning I won't see the client-server jobs running at the bottom. When I connect in, it runs a query, and what it does is it brings me back a list of my HCISs as well as my databases. For Magic, it'll bring back a list of your directories and databases, along with segments. So here, if I wanted to pull admissions data, I can choose the ADM database and then do a simple select statement, selecting everything from the ADM pat main data structure. If I parse this query, you can see kind of what's going on behind the scenes here and what data structure I'll actually be accessing. In this case, I'm going into the ADM pat main. I'm going to return the URN, the account number, admit date, admit time, so on and so forth. When I execute this query, it will bring me back a list of everything in the ADM pat main data structure, and it brings it back in this nice, easy to read relational format. Now this is obviously an inefficient query selecting everything from the ADM pat main data structure, but we have ways of making things a little more efficient and just getting the data you're actually interested in. For example, if I want just a patient's name, I can say select ADM pat name from ADM pat main, and this just returns a list of all the patient's names. Columns are separated by commas. So, and now I want the admit date as well. I don't have to alias the columns, but I can, and all I have to put is as and put the name of it in brackets. If I don't want an alias a column, it will give me the NPR definition for the name of the column. So now I'll get three columns back: my name, my admit date, and my discharge date. I can also manipulate the data being brought back. I can say I want this to be 8 characters long, and I want to use a date-time function. And what this will do is it'll format the date coming back in a nice, easy to read month, day, year format. If I spell it correctly. Month, day, year, separated by slashes. Now, in order to begin querying, I first have to load a schema. So in this case, schema's already been loaded, it's already been built. I can browse this schema. So I've been pulling from the ADM pat main data structure. So if I wanted to see what's in ADM pat main, I can use my browser tool to find that information. For example, adm.pat, and I can do a search for DPMs, and it brings me to the ADM pat DPM. The way the data is stored internally in the Meditech hierarchical data structure is you have DPMs, and if I cascade this down, I have a list of segments within that DPM, and then I have elements or fields, which are fields within each segment. So if I want to go down to the main data structure, I just type in the word main, it brings me down there, and now I'm into the ADM pat main segment, which we treat as a table. So account number, admit date, age, bed, birth date, these are all fields within the ADM pat main segment. So the main segment will be a table to us. If I do a segment hierarchy, I can see how the data is stored in the segments that are under the ADM pat main data structure. So I have a segment, main, account, warnings, allergies. These are all segments that are under the ADM pat main data structure because of the hierarchical Meditech data structure. If I click on any one of these fields, it gives me the attributes of the fields: the addresses, the locals, the data type, the field length. So I can, if I'd like, drag and drop fields from here. So if I wanted a patient's birth date, I can drag this and drop it right over here. I'll separate it by a comma, and I'll call this as as date of birth. Other things I can do is I can actually use the physical addresses. So I can say I want to use this as opposed to the NPR definition. As DOB2. They will return the same value. They're both returning the patient's birth date. You can see here they all match up. The browser also allows me to do partial name searches. So if I'm just interested in looking for a field, I think it's coming from the ADM-PAT data structure, the field I'm looking for is insurance. I can do insurance, and then this will give me everywhere within the schema that's been loaded that contains ADM-PAT insurance. So it looks like under ADM-PAT there's a segment called insurances that contains the field I'm looking for, insurance. So if I want to get my insurance, I'll have to actually go down and join to the insurances segment, because insurances is under the main segment. So what I'll do here is I will say ADM.pat insurance as ints and join ADM.pat insurances. And now I get back the patient's insurance along with that other information. If I did not do my join here, I'll end up with a null value for the insurance. That's because I got to go down one level to the child segment to get the insurances. Other things we're able to utilize with OpenGate is metatext possessors. So I can say adm.pat.insurances.name as its name. This will join over to the insurances dictionary to get the full name of the insurance as opposed to just the mnemonic of the insurance. So now I have the full name of the insurance as well. Additional things I can do to make my query even more efficient are add indexes and where clauses. So in this case, I've been getting back 3,472 rows in a little over a second. But if I'm only interested in patients that have been discharged, I can use the discharge index. We treat indexes just like tables. So now I'll only get patients that have a discharge date. In many cases here, these patients haven't been discharged. Now if I use the discharge index, I'm only going to get back patients that have been discharged. If I look under messages, I'm now getting 405 rows back as opposed to 3,400. And I'm doing it in 270 milliseconds. It's a lot quicker. So being able to utilize any of metatext indexes is going to help your queries be much more efficient, bring back a lot less data. I can use the browser to see those indexes. So I can say, do a search by DPM, and cascade this down. And what this does is it gives me segments and indexes. Anything ending in index or having an X at the end of it is typically an index. So there's an account index. There is a room bed index, room and bed index, and if you click on these indexes, it also gives the fields. So bed, room, facility are all in the room bed index. I used the discharge index, which is a list of discharge patients. Other things I can do is add a where clause, where adm.pat.admit.date is going to be, or I'll say the discharge date, greater than or equal to a date I specify. So I'll grab one of these discharge dates. And now when I run this, I get 348 rows. So I just shaved off several additional rows just by putting in this where clause. OpenGate also allows for parameters. So I can say parameter, we'll call it this date. So instead of hard coding a value for the discharge date, I can say this date. Now every time the query is executed, it will prompt me for a discharge date. The benefit of this is it will speed up the query. Helps with efficiency because it doesn't have to build the query. It's already been built, it's stored in memory, so now you're just passing in variables. So now I'll put in my discharge date, I'll execute the query, and now if I look under messages here, I can see we're bringing back 348 rows in 174 milliseconds. So very, very quickly. Additional queries. So very similar to what we were doing before, I'm utilizing the discharge index in this query. Other things that you can add in this case, I added a little snippet of magic code here, which will allow me to bring back just the patient's last name. Without this, it brings back the full name of the patient. For example, in our last query here, we have patient's last name, comma, first name, when I said select ADM Pat name. In this case, we add pound, quote, 0, comma, quote, and what this will do is bring back just the patient's last name, everything to the left side of the comma, position 0. The birth date, we formatted out with the date time function. We're also bringing back the age, the admit date, discharge date, and you'll notice down here, for the run date and run time, we're using a Z function and S of 0. S of 0 is an internal date used by Meditech. It's seconds since March 1st, 1980, and we can use that to calculate back date and time of when this was run. Last, we have our where clause with our dis date again. So now this brings back patient's just the last name, an organized birth date, and then the run date and run time. Another thing that makes OpenGate unique is being able to execute multiple selects at one time. So in this case, we're utilizing a parameter again of disdate, and we'll have table 1 will be called patients ADM, table 2 will be insurances. Now what we're doing here is we're adding a level. With multiple selects, you'll have to add a level so OpenGate knows where to look for the data. In the first table here, we're going to look at ADM Pat doctors. So we're going to look into the ADM Pat doctors segment. For our second table, we're going to get insurances. So we're going to look in ADM Pat insurances. I'm saying here with this statement that the parent table will be patient ADM, which is what I called the name of this table. And then the relationship will be URN1 to URN2. So what I did was both the ADM Pat doctors segment and the ADM Pat insurances segment contain a URN. So I said ADM Pat URN and I aliased it as URN1, called it URN1. In my second table here I have my URN and I aliased it as URN2. Now I could call these the same name if I'd wanted to and call them both URN and URN, but I'd want to make sure that here I do the same. URN and URN. When I execute this query, what it does is it brings back two tables. It brings back my first table, patient ADM, and my second table, insurance. Now what this parent relationship does is it allows me to drill in from one table into the next. So for example here, if the patient has insurance information, I can drill in through this patient's information to then see the insurance information. And here is that patient's insurance information. So this is an example of multiple selects pulling from one application. So we're first going through the discharge index, so we're getting all discharge patients. We're joining over to main, doctors, and insurances. And this is run once again off the discharge date. This query is very similar to the last query, but what this query will do is actually, instead of just bringing back data from admissions, it's also going to join over to lab. So I have my first table, which once again is called patients, and the level will be ADM-PAT main. My second table will be called lab results. The level will be lab LSpec tests. The parent is going to be the patients table. The relationship will be URN to patient. When joining between applications, you have to find out what they have in common. So there's two different things when joining from admissions to lab, admissions to pharmacy, between applications that you're going to have to do. One is specifying the database you want to join to. So in this case, I'm pulling from admissions, and then I'm going to join over to lab. So what I'm going to want to do is find the lab database, lab SJM, and I'm going to want to join over to that database, SJM, and put that in brackets in my from and join statement. Once I found the database I want to join to, I'm also going to have to find something that admissions and lab has in common. And I can use my browser for that. So if I go to the ADM-PAT main segment, I cascade it down, I have a list of all the fields in here. I can see that AA is the unique identifier, the subscript for the ADM-PAT main segment. If I scroll down, click on URN, I can see that the local is AA, the address is AA. So what I'm going to do is use that AA to find other applications and other places within applications that I can join to. So instead of doing a search on a field level or a DPM or segment, I will do a search on locals, and this will give me everywhere within the Meditech application data structure that I can join. So different applications, places within the same application. So for example, if I scroll down and I want to join to lab, so I'll scroll down to lab, lab C, I want to join lab LSpec, lab LSpec. The main table contains a field called patient. Patient has that same local as my ADM-PAT URN. So the ADM-PAT URN and the lab LSpec patient are essentially the same thing internally. They're the same value. So this allows me to join between admissions and lab because they both have something in common. Although it's not called URN, it's called patient, the local for it is the same value, that AA. So I'll be able to join lab and admissions. What I do here is I also found that there is an index, a lab LSpec patient X index, which contains a list of those patients. So that makes my join even easier. So I'll join ADM-PAT main, and then I'll use lab LSpec patient X. There's also a PHA-PAT patient X if you're joining to pharmacy. And then what I'll do is I'll join the lab LSpec main, and then I'm going down to the tests level because I want to return the lab LSpec test, the lab LSpec test's name, the result, the patient. So when I execute this query, I end up with two tables once again, a patients table and a lab results table. Here's an example of all the data that's in the lab results table. I have my spec number, I have my collection date, the test, the test's name, the result, and then the patient. If I look in my patients table, I have my patient's name, their sex, their account number, their admit date and time, and their URN. I can drill in through the admissions information for a particular patient here, and if they have lab results, I can drill in and see the results for just that particular patient. And I did that utilizing this parent-patient relationship, URN to patient. If I did not include this in my query will still work. By putting two dashes in front of a line, it comments out that line. So if I execute this query now, it will ignore that line, prompts me for the date, runs the query, and now I'll still get two tables. They'll both have the URN in them, but I won't be able to drill in through my patients table to see my lab results. So now when I open up my patients table, I can see here, I still have that same information, but I don't have my plus sign on the left-hand side here to drill in and see the lab results. Now, if I want, I can take all this information and put it into one table. So far we had multiple select statements populating multiple data sets. This is sometimes beneficial if you're going to be populating tables on the SQL side, creating data sets, is to have multiple selects to bring back multiple tables. But if I want all of this data into one table, I can do that as well. I remove my select statements, I separate my columns with a comma, and now I just have one select statement. My from and join remains the same, and now when I execute this query, it prompts me once again for my date, the discharge date, and now I'll get a list of the patients, but they will be listed multiple times simply because they have multiple tests and multiple collection dates. So I can see here my first patient is listed multiple times because they have multiple tests, but this brought all my data back into one table, all my patients with tests. If I'm interested in bringing all the patients back, whether they have a test or not, what I can do sometimes is use multiple select statements to put the data into one table. So before, where we had multiple select statements and we were putting the data into patients and lab, in this case we have two select statements, select table ADM lab, select table ADM lab. So what this will do is it'll actually, although there's multiple selects, we're going to get one result set because I'm saying put the data into one table. In this case, the level will be ADM Pat main, and the level down here will be lab spec tests. So what this will do is it'll bring back my result set into one table. This one table, though, will have, instead of having just the patients that have lab results, this will bring back a list of all patients, whether they have lab results or not. So for example, if I open up this table here, I can see that some of these patients don't have a lab spec number, a collection date, a test. If I click on the column header, it will bring the values to the top. So as I can see here now these are the rest of the patients that have collection dates, collection times, but this is all within one data set now. Although it's multiple select statements, it's bringing the data back into one table, this ADM lab table. The next query utilizes a check clause. A check clause allows you to separate out your result sets into multiple tables. This is very similar to an outer join. Because we're pulling from the hierarchical data structure and not two relational tables, doing outer joins can be somewhat difficult. What this will allow us to do is say, my first table I will call female. The level will be ADM Pat main, point to the ADM Pat main segment, and I'm going to utilize this check. My check says, if the ADM Pat sex is F, that's what I want to include in my first result set. My second table I'll call male. The level will be ADM Pat main once again, and the check in this case will be for M. So internally, the sex is stored as F or M, and what this is going to do is return two tables, a female table and a male table. And in my female table, I will get all the female patients, and in my male table, I will get all the male patients. And I did this utilizing this check clause. Last, I'm going to show you how you can use OpenGate Query Analyzer to help you write your queries. I'll use the browser once again to find the ADM Pat DPM and all the segments within here. What I can do is drag and drop segments right from the browser. over to here, I'll include my allergies segment, and I'll include insurances, and I will also include the ADM Pat main segment. I can use my options to decide how I can save results out as, or to help me include or exclude things within my query. So I can say use SQL compliant names, and it will change the dots to underscores, which makes it easier to import into SQL. I'm using client server. I'll include the data type, include the primary keys, I'll include the relationship in DPM. Okay. If I highlight these three segments, go to Edit, replace segment with SQL, it will do my from and join for me, and what it will do as well is it does my select statements, including relationships. And because I decided I wanted to include aliases, the character lengths, in this case 30 characters for the URN, the data type, string, whether it's a primary key or not, gives it a value here. So 1 indicates that it's a primary key, 0 indicates that it's not a primary key. So my last table here, level, ADM Pat main, check ADM Pat main. If I scroll up, I have my second select statement here, which is insurances, and it utilizes that parent relationship, saying that my parent table will be ADM Pat main, the relationship is URN to URN, and my first table will be that allergies table. And once again, it utilizes the parent relationship, calling the ADM Pat main table the parent table with the relationship URN to URN. When this query is executed, it brings back 3 different tables, or 3 different data sets. And I can drill in through the admissions table, the ADM Pat main table, to see the insurances or the allergies. So if I check ADM Pat main, I can now drill in, and I have the option to drill into allergies and insurances. So if I go into insurances, there's no insurance information for this particular patient. For more information, please visit us online at www.blueelm.com or by emailing us at support@blueelm.com.